Today we're going to continue looking at section 3.4. So we're going to use special segments, but this time we're going to look at them in proofs. We're also going to use something called an auxiliary line. All right, so we are going to be proving that two triangles are congruent. There are quite a few triangles in this problem, so I would highly suggest that you sketch the picture, but then I'm going to highlight the two triangles that we're going to prove congruent. So we're going to be proving this triangle, my pen will work, triangle ABE. So that's my triangle in yellow. And we're going to be trying to prove that that's congruent to the triangle of ACD, which I have here then in green. All right, so we are going to be using our vocabulary that we talked about yesterday. So notice that my first given is that segment CD and segment BE are altitudes. And remember, that is a vocab word from yesterday. When you are given an altitude, remember an altitude is going to start at a vertex and it is perpendicular to the opposite side. So essentially, anytime we're thinking about altitudes, we're thinking about right angles. Okay, and so because we know what triangles we're trying to prove congruent, we need to look at what right angles are being created within the triangles that we're looking to prove congruent. So if I start and I look at the segments CD, we'll notice that it is then perpendicular to the segment AB. So hopefully we're okay with noticing that it's this angle right here. So that's angle ADC. That's going to be a right angle. So I'm going to state that it's a right angle, but because there are two altitudes, I also want to look at the segment BE. That's going to be perpendicular to the segment AC. So that means that the right angles are happening at E, but the only right angle that's absolutely necessary for us would be the right angle inside of that yellow triangle. So that looks like that would be angle of AEB. All right, so angle ADC and angle AEB are right angles. So now I have to justify why I know this. But remember, I know this because of the vocabulary word of altitude. So we would say if a segment is an altitude, because remember the if part is what's given, and we were given that we had an altitude, then it forms right angles. So this reason is very, very similar to like if we were given perpendicular. If we're given perpendicular, perpendicular forms right angles. Well, now if we're given an altitude forms right angles. Remember, because I have two right angles, we can keep expanding on this. If I have right angles are congruent. So my third step is that the angle ADC is congruent to the angle AEB. And so remember, if two angles are right angles, then they are congruent. All right, so we have one thing marked in our triangles that are congruent. Let's go ahead and let's look at our next given because I've used altitude and I've expanded on that vocab word as much as possible. So we are given that the segment AD is congruent to the segment AE. And I'm going to go and mark that in my picture. So segment AD, I'm going to give one tick mark. Segment AE, I'm going to give one tick mark. All right, so that gives us only two things that are marked in our picture. In order to prove that I have congruent triangles, I need three things. So the fact that I highlighted the two triangles we're looking at, notice that where those two where they highlighted, they actually overlapped at a particular piece. Notice that both of those triangles contain the same angle A. So because it's the exact same angle, remember, we can have angles congruent to itself. So I'm going to say in step number 5 that angle A is congruent to angle A. Because there's only one angle, I only had to use one letter. If there were more than one angle A, we wouldn't be able to state this. But remember, something is congruent to itself because of the reflexive property. So now I can mark that in my picture. And now I do have 3 markings. It might be kind of hard to see. So like if I really quick drew this out here, like there's my right angle, there was this angle, there was this marking. So notice we have 2 angles. We have a segment that's in between them. We do have enough to prove that these triangles are congruent. So triangle ABE is congruent to the triangle ACD. And from the markings, hopefully we're okay with noticing that this is because of angle, side, angle. But now remember, I want to go back through my proof and I want to list the step where I had those congruent pieces. So A is first. Where was my first set of congruent angles? Well, if I'm looking at my list, it's not until step number 3 that I have angles congruent. Step number 4 is where the side came into play, and then step number 5 gave us our other angle. So we are done with this proof. If we take a look at this next one, we are, once again, I would suggest that you sketch the picture. We're trying to prove that we have congruent triangles. So I'm going to write down my first given. I know that the segment AD is congruent to the segment CD because it's given. I'm going to mark that in my picture, AD and CD. I can move on to my next given because I don't have any vocab words with the first one. So the next thing is that the segment DB is a median. Now remember, a median is a vocabulary word that we talked about yesterday. A median starts at a vertex and goes to the midpoint on the opposite side. So if we're talking about a midpoint, notice that if DB is the median, it's starting at angle D, that's the vertex. B is going to have to be the midpoint. Well, if I have a midpoint, what does that mean? Well, that means that I have 2 congruent segments. So hopefully we're okay with noticing that it's going to be the segment AB and the segment CB that are going to be congruent to each other. And so my reason would be if a segment is a median, because remember, that's what was given to us, then it divides a segment into 2 congruent segments. Okay, so essentially it's just like if I said if a point is a midpoint, then it divides a segment into 2 congruent segments. Here, though, we're talking about a median dividing a segment into 2 congruent segments. So I expanded on that vocab word. There are no more givens. I want to try to prove the triangle's congruent. I need to have 3 things marked in my picture. Right now, I don't have that. But if you look at the 2 triangles, the 2 triangles share a side. They share the side DB. So remember, we can say that the segment DB is congruent to the segment DB, and that is because of the reflexive property. So we can always get something congruent to itself by the reflexive property. Now I have 3 things marked in my picture, so now I have enough information to state that the triangle ADB is congruent to the triangle of CDB. And if we look at the markings, it looks like it's because of side, side, side. So if I'm looking at my steps, my first set of congruent sides came from step number 1. It wasn't, though, until step number 3 where I had congruent segments again, and then finally step 4 finished it out. All right, we have a postulate. A postulate, remember, is an unproved assumption. So our postulate is that 2 points determine a line. Hopefully that makes sense. If I have 1 point, another point, if I connect them, they're going to form a line. So we're going to use that information in this proof right here. So I would suggest that you sketch the picture. And now we are going to go ahead and I'm going to start with my first given. The segment AB is congruent to the segment AC. And I'm going to mark it in my picture. So AB is right here, AC is right here. I'm giving each of those one tick mark. I'm going to move on to my next given, that the segment BD is congruent to the segment CD. That is also given information. So segment BD, segment CD. I've run out of givens. There's nothing that I can expand on. What we're trying to prove is that the angle ABD, which is this angle right here, is congruent to the angle ACD, which is this angle right here. In order to prove that angles are congruent, remember, we would want to try to look for congruent triangles first. I do see two triangles in this picture. ABC is a triangle, DBC is a triangle, but hopefully you recognize they are definitely not going to be congruent. They are not the same size. One triangle is inside of the other. So this is where we're going to want to use that new postulate that I just mentioned. If I see 2 points that I could connect that will then help me form two triangles that I could get to be congruent, well, that's what we're going to want to do. Notice that we've got the point A and we've got the point D. If I connect them, now I've formed a new segment, and notice that now I've created two more triangles up there at the top. So because I had to draw that in, I have to say that I want to draw the segment AD. And my reason is that postulate, 2 points determine a line. So anytime we have to draw something in, we're connecting 2 points determine a line. So now, because I want to get those two angles, let's focus on the triangles up here at the top. So let me highlight. So we want to try to prove that the triangle of ABD is congruent to the triangle of ACD. We want to get those two top triangles. They already have two sets of markings. We need a third thing. Hopefully you notice that by drawing that segment AD, that's now a side that's shared between those two triangles. So I can say that the segment AD is congruent to itself. And it's congruent to itself because of the reflexive property. All right, now I do have 3 things marked in my picture, so I have enough to prove that the triangle of ABD is congruent to the triangle of ACD. And the markings are because of side, side, side. Notice step number 1 is where my first congruent side is, step number 2, and then step number 4. But proving congruent triangles was not my final conclusion. I want to prove that angles are congruent. Well, remember, because those angles are now inside congruent triangles, once I have congruent triangles, any other pieces of those triangles are congruent. So I do have enough information to go to my conclusion, and the reason why these two angles are congruent is because of CPCTC. Corresponding parts of congruent triangles are congruent. We had congruent triangles, that's why any other pieces are congruent. So that's us using special segments and proofs and using this auxiliary line where we were able to draw in something.